combine functions is through composition. The composition of two functions involves evaluating one function and then using the resulting output as the input for the second function. We perform one function, then perform the second function. As an example, let's suppose we want to buy an item that's on sale. The first step is to determine the new price of the item. This value is then used to compute the sales tax on the item. So we had two different operations that were performed in sequence. Let's suppose we have two functions f of x and g of x. Our composition is written as f with a little circle and then g of x. And this is read f of g of x, and it literally means f of g of x. This means we use our input value into the function g here. We get the output, and we use that as our new input to our f function. So we do need to work from the inside out. Let's consider our two functions, 2x minus 1 for f of x and g of x equal to 5x plus 8. I want to look at the composition. As a reminder, the definition says this is f of g of x. And we always work from the inside out, so we're going to start with g of x. The only thing I know right now is the value of g of x. Therefore, I'm going to rewrite this as f of 5x plus 8, because 5x plus 8 is g of x. This notation now says to look at the function f, and everywhere we see an x, write 5x plus 8 instead. This would give us 2 times 5x plus 8 minus 1. And now we just need to simplify. Distributing, we get 10x plus 16 minus 1, which simplifies to 10x plus 15. So the value of f of g of x is 10x plus 15. Let's instead suppose we want to find g of f of x. So this time when we work from the inside, we're going to start with the function f of x. Since f of x is equal to 2x minus 1, this is the same thing as g of 2x minus 1. This notation now says to take my function g, and everywhere I see an x, change it to 2x minus 1. When I do that, I get 5 times 2x minus 1 plus 8. And now we just need to simplify. When I distribute, I get 10x minus 5 plus 8, which is 10x plus 3. We did get 2 different answers here, and it's very important to note that the order of composition matters. Switching the order of the functions does in fact change the solution. So it is really important to pay attention to which one is listed first and which one is listed second. Next, let's look at how to evaluate a composition using a table. This table here defines 2 different functions, f and g, for the indicated values. Let's suppose we want to find f of g of 3. We always start on the inside, so we want to find g of 3. When we input 3, we can see that g outputs 4. We then use this as our new input. So now we want to find f of 4. When x is 4, f is 1. This gives us that f of g of 3 is equal to 1. This time, let's look at g of f of 1. We start on the inside, so we need to find f of 1. And if x is 1, we can see that f is 3. We then need to use this as our new input. When x is 3, we can see that g is 4. Therefore, we have that g of f of 1 is equal to 4. The evaluation of the composition of functions can also be found using graphs. So let's consider these 2 functions here. We have f of x labeled on the left and g of x labeled on the right. And we want to find the value of f of g of negative 2. Once again, we need to start on the inside and find g of negative 2. If I look at the graph on the right, the g graph, and I go over to negative 2, I can see that the output would be 2. Therefore, we have f of 2. We're going to use that output as our new input. If I look at the graph on the left, the graph of f of x, and I go over to 2, we can see that the output would be 3. Therefore, we have that f of g of -2 is equal to 3. Next, let's suppose we want to find the value of g of f of 2. Starting on the inside, we need to find f of 2. So we go over to 2, and we can see that the output is 3. I then use this as my new input. The graph on the right, the g graph, if I go over to 3, I can see my output is -1/2. Therefore, we have g of f of 2 is -0.5. When using equations to evaluate the composition of functions, just as with graphs and tables, we start on the inside. If I want to find f of g of 1, my first step would be to start on the inside and find g of 1. Plugging in 1 into my g function gives me 5 minus 3 times 1, which simplifies to 2. So this is the output, and we're going to use it as our new input. So now we need to find f of 2. Plugging in 2 into f, we get 2 squared plus 2 times 2, which is 8. This gives us that f of g of 1 is equal to 8. Next, let's look at g of f of 1. Working on the inside, our first step would be to find f of 1. Plugging 1 into my f function gives me 1 squared plus 2 times 1, which simplifies to 3. And now I'm going to use this as my new input. Now we're looking for g of 3, so I'm going to plug 3 into my g function. When I do that, I get 5 minus 3 times 3, which simplifies to -4. And this gives our final solution that g of f of 1 is -4.